I'm going to go back to page 36, and we're on polynomial inequalities, and to remind us that there is actually a graph behind this inequality. The inequality says, essentially, I want to find where x plus 1 squared times x minus 1 is less than or equal to 0. This says where y is negative or equal to 0. And the first thing that we did is we went in and we set this thing equal to 0. Yeah, we're revisiting it to get the zeros. And we found that x was -1 and x was +1. -1 was multiplicity 2, and +1 was multiplicity 1. That was this point right here, and this one right there. And then we found that if we had multiplicity 2, that the graph touched. So there was no change in y. So I would normally either put a T there or actually put an N there, meaning no change. Which means if y was negative, it stays negative. If y is positive, it stayed positive. And then at 1, I noticed that y, and this would be for x equal 1, which is multiplicity 1, that the y values are negative on one side and positive on the other side, so that the y values changed. Or you could say cross, because the graph crosses. And I want to know where it was negative. If I just had the number line, namely the x-axis, I noticed that y is negative from -infinity to -2. And because this is a solid dot, it continues on until +1. And the answer is in terms of x values, that for x equal -infinity to +1, including, because it includes the x-intercepts, y is less than or equal to 0. Okay. In our next series of problems, we now, and when you're going to be doing this in calculus, you remove the graph completely. And all you're going to be doing is you're going to be working with just the number line. So if I looked at this, this says y is negative, y stayed negative because there's no change, y moved positive because the graph crossed the x-axis, and then I would shade where it's negative. So that would be my information. My answer would be where I saw minus signs. Okay. So here we go. So I want to know where x minus 5 times x plus 2 squared is positive. Now, what this means is that y is positive but not equal to 0. This means I exclude the x-intercepts. And these problems are all work the same. The first thing I do is I go after the zeros. I solve the equal equation. The equal equation is finding the zeros and their multiplicities, which is what we did when we were operating off the graph. So this is where x minus 5 times x plus 2 squared equals 0. Now, since I don't include the zeros, which are the x-intercepts, that when I go to my number line, these guys are open dots. And that means exclude that number. Well, this gives me that x equals 5, and x equals -2. This is multiplicity 1, and this one is multiplicity 2. Multiplicity 1 means I do have a change in the y values, and multiplicity 2 means it touches, or there is no change in y. So if y is negative, it stays negative. If it's a positive, it stays positive. Solve the not equal equation. Well, not equal equation means domain restrictions. In this instance, because I'm dealing with x minus 5 times x plus 2 squared, the domain is all real numbers, so I don't have a problem, so there are none. So with polynomials, no problem, there's no domain restrictions. Then what I'll do is I set up the information I have on the number line. The number line is really the x-axis. So that says I draw the number line, which is the x-axis. I place the zeros on the number line. The zeros are -2, it doesn't include, so it's an open dot, and +5 doesn't include, it's an open dot. And then I want to know where is the graph above and below the x-axis. Well, the big thing is at -2, it's multiplicity 2, so there's no change across -2. Graph is going to touch. That means if it's positive, it stays positive. If it's negative, it stays negative. And here, the graph crosses. So it either moves from positive to negative or negative to positive. Now, all I need is one test point. I'm going to pull my favorite. My favorite is x equals 0. That's going to be my test. And then it falls like a set of dominoes after that. So I want to know if x equals 0, am I looking at y positive or y negative in that region? Well, this would be 0 minus 5 times 0 plus 2 squared, which is minus 5 times +4. Is it a positive or a negative number? Negative. So that says y is negative here. No change, which means it's negative, it stays negative. Crosses the axis, which means it's negative, it moves to positive. And what am I looking for? By the way, in calculus, you want it all, which is not unusual. You want to know where you have both positives and negatives. But in this class, we want to know where y is positive. So I want y strictly greater than 0. And that says it's this right here. So it's easy now to get the answer. It just drops down from the number line. It's 5 infinity. So as long as you give me x values between 5 and infinity, not including 5, then the y value will be positive. In calculus, by the way, this information tells you where the original function is increasing and decreasing. Positive means increasing, negative means decreasing. And you're doing this on something called the derivative.